Alright, so today we'll be covering the product rule for derivatives. The product rule is defined as d over dx, which can also be written as the function f of x or y in reference to y, as f times g, so two factors. The derivative is equal to the power rule derivative of f times the original function of g plus the original factor of f times the power rule derivative of g. So with as an example, I will be showing this equation, y is equal to 3x minus 2x squared times 5 plus 4x. Now the y is different to d over dx, but they do mean the same thing. So, thinking of it like this, this is our f. Shoot, that's why I don't use my left hand. Okay. And this is our g. And that's a bad idea for the paper. Okay, so. There we go. So in this case, the original f is the one I showed earlier, and g is the same as well. So the power rule, very quickly, is defined as, using similar terms, is d over dx of x to the power of n is equal to x times n minus, n times x to the power of n minus 1. I'm looking at the camera right now, not the paper, like I should be, so this is kind of messing me up a little, but it's okay. I will get through it. Hopefully. So, with that in mind, we have, darn you notebook, we have the power rule of the function f, which is this one right here. So in this case, x has an invisible to the power of 1, so when you change that, it's going to be x, or it's going to be 1 times 3. And then this is reduced to 0, and anything to the power of 0 is equal to 1, so it's basically 3 times 1 times 1. So we're just left with 3 minus, and then going back to this part right here, so we have 2 times 2, which is equal to 4, and then subtract 1 from 2, which leaves us with the 1. So this x is to the power of 1. Similarly, here, since 5 already has an x to the power of 0, when you reduce that further, or even then, when once you multiply, it's 5 times 0. Anything times 0 is 0. So this is taken out almost entirely, or it is taken out entirely. Basically, just it's 0 plus 4x, and then 4x, like this one is technically a 4x to the power of 1. So with similar things that I did for this one, apply that here, and the g function is now 4. So simply plug that in. So this is our derivative times, derivative of f times the original g, original f times the derivative of g. I think I said that right. Derivative f, g, original f, derivative g. Yeah. So you end up with this huge cluster of numbers. So the ones that end up being most effective here, so to speak, is that this is all from this, and this is from here. So from that, you would end up combining like terms, or really what you'd end up doing is rearranging it to make it more manageable. At least that's what I do. So it's easier to do combining like terms, so it's turned out to be negative 16x squared minus 8x squared minus 20x plus 12x plus 12x plus 15. So from that, right, that was another thing. So from there, we go straight to combining everything at once. And if you want to see the math for that, in case some people might have difficulty with that, here's all the math. So, yeah. In this case, I added them because they're both negatives, so I was just trying to make it easier on myself. So it's negative plus negative. I just put the negative sign in back afterwards. So we are left with negative 24x, notebook plus, negative 24x squared plus 4x plus 15. And if we wanted to do a second derivative, which is just follow the same thing for here, if anything, any rules apply. Wow, that was terrible. Okay, so but in this case, it is just a straight power rule, which is just that for each term. So this becomes 0. So this is technically plus 0 if you want to make it like everything connects. But like before with the 3x and the other 4x, this is reduced to 4, and then 2 times 24 is 48. So we have negative 48x plus 4. Which is really a low number. And, yeah.